Dear students, now we discuss parallelogram rule of vector addition. Here in the parallelogram rule of vector addition, we just see the statement. It says to add two vectors, we place both the vectors at a common point, common starting point, and we complete the parallelogram using these two vectors as adjacent sides of the parallelogram. And let's draw it. Say for example, we are having a vector A and another vector B, which is at an angle theta with the positive direction of x-axis. If we want to draw a parallelogram using these two as adjoining sides, first, as we can see, to add these two vectors, we place both the vectors at a common point. Now, if we place both the vectors at a common point, say this vector A, and here this is our vector B, which is at an angle theta. Now, using these two sides as adjoining sides or adjacent sides of a parallelogram, we complete the parallelogram like this. Now, in this situation, it is further saying now the diagonal of the parallelogram between these two vectors gives the addition vector. The diagonal between these two vectors is this. This is our C vector, which is representing the addition vector. And you can see this is just an analogous situation of triangle rule also. So if this vector A and we displace vector B here, this will be vector B. And if vector A and vector B are drawn one after another, the resulting vector will be drawn from the starting point of A to end point of B. This is also vector B. So we can simply state this vector C is giving us the addition of A vector and B vector. And along with this, it is also saying the other diagonal gives the subtraction vector. So if we draw this diagonal, so this is a vector D. Here we can write D vector is equals to A vector minus B vector. And you can very easily verify this statement also. Like here in this triangle, you can see vector B plus vector D is giving us vector A. Here vector A is the resultant for vector B plus vector D. If you take this B vector on the left hand side, you are getting the same situation. Vector B plus D gives A. So here this is also verified that the diagonal, other diagonal of this parallelogram, which is drawn from one vector to another vector, gives us the subtraction of these two vectors, that is A vector minus B vector. Now we'll discuss the way to calculate magnitude and direction of resultant vector in a parallelogram rule. We have just now studied that if we consider two vectors, one is vector A and other is vector B, and say B vector is at an angle theta with the positive direction of x-axis. If we wish to find out the resultant vector for the addition of A vector and V vector, we just draw both the vectors at a common point. This A vector, this B vector is at an angle theta. And we complete the parallelogram using these two as adjoining sides of the parallelogram. For this, we just need to place a vector A over here and B over here. The parallelogram will be completed. And here the middle diagonal of this parallelogram, C vector, it gives us the resultant of A vector and B vector. Now say if the angle which C vector makes with the positive direction of x-axis is alpha and its magnitude is C. So we can very easily calculate the value of C and alpha by using the concept of rectangular components. Here if this is the vector B, if we place this vector B over here, again this vector is B and this angle is the same angle theta. Now if we draw two perpendicular components of this vector B by drawing a perpendicular from this point to the x-axis, we can see this is the x component of B and this length is B cos theta. And here this length can be written as the perpendicular component or rectangular component of B, which is opposite to the angle theta, it is B sin theta. Now this magnitude of resultant vector can be written as this square plus this square by simply using Pythagoras. So here I can say c square is equals to a plus b cos theta whole square plus b sin theta whole square. So here the resultant vector c can be, the magnitude of resultant vector c can be obtained by squaring and adding these two terms. It gives us a square plus, you can see the term b square cos square theta and b square sin square theta will combinedly become b square. And one more term will be left over here, that is 2ab cos theta. This is the resultant which is directly obtained by parallelogram rule. We can just name it as equation 1. Your angle alpha can also be easily obtained by finding out the trigonometric tangent ratio of this angle alpha. Your tan alpha can be written as b sin theta upon a plus b cos theta. It is b sin theta upon a plus b cos theta. So here angle alpha which the vector c makes with the x-axis can be written as tan inverse of b sin theta upon a plus b cos theta. This is equation number 2 or the second formula of parallelogram rule, which gives us the angle made by the resultant vector with the direction of one of the vector. Here, if we are required to write the value of c vector, the resultant vector, it can be written as c angle alpha, which can be directly obtained. The value of c and alpha are given by equations 1 and 2. Let's discuss an application of parallelogram rule, that is vector addition of two equal magnitude vectors. Say we are having two vectors which are of equal magnitude and at some angle, say theta. Say both the vectors are of magnitude a and a, but they are inclined at an angle theta. And say we are required to find the sum of these two vectors, that is say resultant vector r. So using parallelogram law, we can directly write the value of r can be given as root of a square plus 2a square cos theta. Here we are directly using the equation 1 or the formula 1 result of parallelogram rule, which gives us the magnitude of resultant vector. Here the magnitude of resultant vector can be written as, here we take a as common out, this 2 plus 2 cos theta, which we can write a root of 2 into 1 plus cos theta. And I think all of you are aware about the half angle identity, that 1 plus cos theta can be written as 2 cos square theta by 2. If we put it here, this will become 2a cos of theta by 2. So the resultant of two equal magnitude vectors can be directly written as 2a cos theta by 2. So be careful about this result. Let's take up an example based on this result also. In this example, we are given with two forces, each of 40 Newton in horizontal plane. They are acting on a 5 kg mass at an angle 60 degree with each other. And we are required to find the acceleration of the mass. We know very well that the acceleration of mass is equals to force upon mass. We talk about the acceleration, it can be written as total force or the net force acting on the body divided by its mass. So we talk about the net force acting on the body. Here we are given with the two forces. Say they are F1 vector and F2 vector. They are acting. The resultant is F net. Here the magnitude of both the forces 40 Newton. And it is also given that they are acting at an angle 60 degree with each other. That is the angle between F1 and F2. So if we draw the situation, this is the case when we are having a 5 kg mass. Two equal forces are acting at an angle 60 degree between the two and they are having same magnitude, say F, it is 40 Newton, this is also 40 Newton. So the resultant can be directly given by the expression which we have just covered, that is 2F cos of 60 by 2. So this will be 2F cos of 30 degree, that can be written as root 3F. So here it will be 40 root 3 Newton. This is the net force acting on this 5 kg body. So the acceleration of this 5 kg body can be written as 40 root 3 divided by 5 is 8 root 3 meter per second square, which is our answer to this question. Let's take up another example. Here we are given that if A vector is 10 angle 30 degree, B vector is 20 angle 60 degree, we are required to find the resultant vector, which is the sum of vector A and B, that is vector C. So here we are going to use parallelogram rule, and in solution here we can say the magnitude of A is 10, magnitude of B is 20, and the angle between the two is 60 minus 30, this is 30 degree. Here you can see the vector B makes an angle 60 degree with the x-axis and vector A makes an angle 30 degree with the x-axis. So angle between the two vectors is 30 degree. So here we can simply say by parallelogram rule, this vector C will have a magnitude given by root of A square plus B square plus twice of A into B into cos of the angle between the two, that is cos 30 degree. So this will give us root of this 100 plus 400 plus 400 into root 3 by 2. So here the magnitude of the resultant vector can be directly given as 500 plus 200 root 3, or it is 10 root of 5 plus 2 root 3. This is the magnitude of the resultant vector. We can also find out the angle made by vector C with vector A. So angle made by C vector with A vector, this can again be directly given by this, can be given as, we are having the direct relation from parallelogram rule, this angle alpha can be written as tan inverse of B sin theta, that is 20 sine of 30 degree divided by A plus B cos theta. So here we can write it as tan inverse of, and this tan cancelled out, this will be 1 upon 1 plus root 3. So this is the angle made by vector C with vector A, and we can see vector A is at an angle 30 degree with the x-axis. So here vector C can be written as C angle of 30 degree plus alpha. This is our answer to this question.